everyone. My name is Katie. Today I'm going to talk to you about unlocking the potential of fault detection and diagnostics on your campus. I'll give you sort of an intro to the definition for fault detection and diagnostics and hopefully show you some real world examples of workflows and then also some tangential benefits that some users of the technology have seen. And I'll finish up with kind of some recommendations for what to take with you from this to your colleagues back at your universities. But first, I'd like to start by introducing myself a bit more. So just about 4 or 5 months ago, I was like you. I worked in facilities management for the University of Iowa. I started out as an energy engineer working in the private sector as a consultant, and then made the move over to the university. And I was there for about 6 or 7 years. On the energy management team, and then also working in their building analytics group to help to build their fault detection and diagnostics program there. So I have a lot of the knowledge of the aches and pains of facilities management, specifically operations and maintenance organization, and then also some of the lessons learned from implementing fault detection and diagnostics on the university side. I now work for a fault detection and diagnostics provider known as Clockworks Analytics. I am going to mention that once, and then I'm going to stop talking about the provider that I specifically work for and try really hard to give you kind of a broad vision of what the technology is, and hopefully give you some tools to make the decision for what provider fits you the best. Because I really do believe that it is a partnership if you're going to implement this properly, and you want to have a good feel for what that partner will provide for you and how it matches with your organization and going forward. Okay, so once again, let's go over learning objectives really quickly. So we're going to talk a lot about the definition and what really makes something fault detection and diagnostics, differentiate that from your building automation system, your building management systems, and those alarms that you have there. I'll give you some real life examples of a workflow working through 2 different fault examples from start to end. We'll talk about how you can really use FDD as a foundational part of your operations and maintenance organization. And then we'll talk through some important things that I think are important to discuss with your providers if you're looking to implement this on your campus, some things to include in your RFP if you're going out for bid on this. And then we will have questions and answers. All right, so let's talk about definition. Let's start with a foundation here. So this is a quote that I like to share from Thomas Friedman. And it really talks to the idea of weak signals. So if you have been in a maintenance organization for 30, 40 years, you have the institutional knowledge to walk into a mechanical room and hear things that might be going wrong, see things that might be going wrong, and troubleshoot things with sort of, I expect to see the damper in this position, I expect to see the valve here. And with our sequences and the way that we operate buildings becoming more and more complex as there's more data coming into us, it's coming at us more quickly, there's more change of states and more modes of operations, it gets a lot harder to have that institutional knowledge in your back pocket. It takes a lot longer to get there. And some of our new construction buildings, it can take years and years to get familiar with how they operate. And it can be really difficult to pick up on those weak signals. So that's those things that are sort of change of state within the mode that could be going wrong. And so fault detection and diagnostics is really a tool that helps to find those weak signals, that needle in the haystack, and make that just normal operation instead of I found this really cool thing once every couple weeks or couple months. So we really drive home the emphasis that FDD is truly a colleague. It enables those technicians to find weak signals together. So it's not something that will replace a technician in the field. Someone also always needs to make that decision. Someone always needs to interact with the tool and fix the problem. But it can be sort of a colleague that goes alongside you to help you troubleshoot and find those problems maybe a little bit faster. And I'll show you some examples of where that's been instrumental. So real broad brush definition of fault detection and diagnostics and how that corresponds to finding this needle in the haystack. So your building automation system, your building management system, I'll call it a BMS from now on, is what operates your HVAC system in your building and potentially your lighting system. Let's focus on just HVAC for this example. So you have lots of data that's coming in, different data points telling you temperatures, valve positions, damper positions, and all that information comes in, and your building on your BMS then tells it what to do and will sometimes alarm if something is far out of range to the point where it needs a quick response. An example of that would be your air handling unit is discharging a very high temperature right now, and it's serving, and that's all you know about it. Fault detection will give you another layer of information. So it lays on top of your building on a BMS system. It pulls in information and data from your BMS and maybe some other potential data sources such as your metering systems or your lighting systems. It pulls it all into one. And then it will also pull in historical information, the logic that's written within your building automation system. So any of those sequence of operations, your FDD system, that colleague knows that information in real time. And then it also knows the type of equipment you have. So instead of just telling you your air handler has a high discharge air temperature, it tells you the air handler has a problem that's been occurring for 3 straight days. And it's big. It's a big air handler. So it's one you might want to pay attention to. The last little D there, so when we say FDD, we're talking about fault detection and diagnostics. So that last little D there is really the really big important piece, and that takes assigns a cost to the problem. It does some engineering, and it also knows what other systems might be impacted by that. So the example here, one more level of detail would be the preheat valve is stuck open. So I actually know it's the preheat valve because I know my logic, I have some engineering, I know what type of equipment I have, and it's impacting the perimeter zones only on the 3rd floor, and it wasted $315 in 3 days. So it's really taking that extra bit of information, giving your technician even more information at their fingertips to decide whether they need to act. And then when they act, they know what to do without spending a lot of time doing the research. So how does this work? So I'm going to show you an example of, I tried to sort of anonymize it, but this is how Clockworks does it. Lots of providers do it just slightly differently, but the principles are the same here, where they take the BAS information and they pull it into some form of protocol translator. So your BAS is communicating in some sort of language, and they will have a translator that will take that language that the BAS is creating in, whether it's BACnet or whatever that protocol is, and it will translate it into something that your FDD provider can consume, and it'll transfer that data. Sometimes it's cloud-based, sometimes it's a local server, but this is a really important thing to talk to your providers about when you are looking to implement this on your campus, because it will most likely have IT implications. And sometimes facilities management and IT don't talk at the early stages of things and understand what are potential hiccups. So this is an important thing to know when you're talking to a provider and to involve your IT in an early phase to make sure that it's ready to go and you're not going to get any hiccups. So the next phase is the data model. We're going to use an air handler as an example. And you're going to take your BMS data, your control sequences, and your equipment schedules. And I'll give you a little bit more. I'll just give you an example with an air handler of how that works. So right here below, you have a typical AHU, right? It's 100% outside air. It's got some dampers, some coils, some fans, some temperatures. So your FDD system will take that BMS data. It'll pull in your outdoor air temperatures, any of the data that it needs to make those conclusions and those. Can you guys hear me okay?
Yes.
Okay. And then it will also your FDD provider will input the control sequences. So what it would expect your system to do into your fault detection and diagnostics program. And so then it lives there real time, live, and it knows. The example that's given here, is how your economizer works. What are your high limits, and how is it controlled? And then it'll take those equipment schedules. So how big is my fan and what's my rated flow? And that's instrumental in deciding that cost, right? It uses that to determine how much is this going to cost me to fix and how big of a comfort impact potentially is it going to be? How big is my equipment? So it'll create this data model. And then you as a user will have an output, right? Typically, your FDD providers will be giving you this information with some key performance indicators. Some common examples are energy, comfort, and maintenance. That's something that people talk about a lot in the industry, is quantifying how big is my energy impact, how much is my comfort of my occupants impacted, and how much is this going to impact my maintenance bottom line. So they're trying to quantify these things so that you're not just given an alarm that gives you no information about, do I need to act on this or not? It just says, go do it. It's giving you a little bit more information so you can prioritize your work. And then it'll say, okay, of those, these are the top things, right? So if energy is very important to your campus, these are the top things that you should be responding to: the simultaneous heating and cooling fault, this economizer override fault, and this reset sequence. And you as an organization can kind of decide, where do my priorities lie and what should I be responding to, so that you don't get weighed down by alarm fatigue, basically, right? You want to be able to prioritize and make smart decisions about where you spend your time and how you do your work. And then finally, it'll give you a cost savings. Typically, that's energy savings at this point in the industry. I think there's a lot of conversations around where that can go outside of just energy, but at this point, that is typically where they're talking about cost savings. It's energy, but again, that's another thing to ask your provider as you're kind of interviewing folks. All right, so we're going to do a little bit of a deeper dive of the difference between an alarm and a fault. Because I get this question a lot. I had this question a lot. Iowa would talk about this frequently. And so an alarm, here's an example, right? So you have an air handler again, and your alarm, let's say, is looking for a discharge air temp that's high. So if you saw an alarm come in as a technician, it just says high discharge air temp. So when you get that alarm, you don't know when it started, how severe it is, if anything else is impacted, what is the root cause or how to fix it, right? You have to go search that out and do the investigation before you take action. If you have fault detection, you know, if you get that high discharge air temp fault, you know when it started because you have some history, right? They bring that to you. You know how severe it is because maybe you know that it serves a lab space. Maybe you have prioritized lab spaces to have a higher maintenance priority. So that would come to the top for you. You know if there are other issues present on this piece of equipment. So you know, I see a high discharge air temp, but I also see a mixed air temp sensor fault, and that I'm not utilizing free cooling. So you're putting those pieces together. You have a little bit more information, but you still need to do a little bit of investigation before you take action when you get to the root cause. Now, fault detection and diagnostics will help you get that over that finish line. So you'll say, I know when the issue started. I know how severe it is. I can even put a cost to it. I can say it's $300 per day if I let this continue. I can tell if there's other issues present on this piece of equipment and potentially other pieces of equipment. If my air handler is in fault, are my VAV boxes that are impacted by that air handler also in fault? And then it also helps to tell you the root cause. So it takes all of this information. It says, I know I have these 3 problems. These are the recommended steps you should take. Either you need to adjust your PID, you got to adjust your sensors, or you have to do a change to your economizer control sequence. Those are the 3 top recommended steps. So right there, you have some actions to take right out of the gate. So it really saves a lot of desk time and time in the mechanical room, troubleshooting, and potentially going to get the part to come back, right? So when we talk about a fault, a lot of the things I would also get, a lot of questions I still get, and I would get when we were doing this on the campus I was at, is why is this any different than just doing this in your building automation system, writing this as an alarm, but just adding this little nuance to it so it can kind of be like a fault. And so I'm showing you this very simple example to show that it's not so simple. So when you are looking at a fault for a zone being above or below set point, the reason this is a nice fault to have is when you're looking at a campus environment, you all know this, you have thousands of zones everywhere. And being able to track whether they're all in compliance is a very difficult task. You're really, for the most part, waiting for a comfort call. You're waiting for the occupant to be uncomfortable enough that they will call into your work control center. And so this is a nice fault to have, because you can kind of see, oh, I know all of the zones that are out of compliance on my campus. I know how far they might be out of compliance, and I can go hit the big hitters. So easy. Let's look at when the zone's occupied, what's my set point, and what's my room temperature. So I say when my room air temp is higher than my set point, when I'm occupied, I want to know. Easy, right? You just take that fault, you copy it, and you paste it all over campus in all of your zones, right? No. So you probably know this too, but in my experience across campuses, depending on when the building was designed, who did the programming, who did the design, that what calling something occupied is not always the same. In some buildings, you might have an occupancy status point. In other buildings, you might just have to look and see if your VAV damper is open, and then you know it's occupied. There are different things that would indicate that your zone is occupied. And then you'd need to know in some cases whether your zone is in heating or cooling. It's not always the same point that you're looking at in the BAS system to determine that. And then what is your actual set point? Sometimes you have ranges, sometimes you have occupied heating and an occupied cooling set point, and sometimes you have the really easy effective set point, but not always. And so it becomes, when you start to copy and paste that, each time you're putting it on a new zone, you're customizing it. And then it becomes very difficult to maintain and to keep it going. So this is an important thing to ask your providers about maintenance of the fault. What is your fault detection and diagnostics program going to look like on day 1? And what is it going to look like on day 100? And how long is it going to take you to get there, right? So if you have to customize each one of your faults all over campus, it's going to take you a really long time before you have actionable information. And then if something were to change, how long is that change? How does that change management happen? How long does it take? That's an important nuance. Okay, so we're going to get into it, and I'm going to give you a day in the life. Sometimes definitions are great, but seeing it in action, I think, can really drive home the benefit of FDD and why it might be a good thing for you guys to bring back to your campuses. And I'm going to emphasize this one more time, that fault detection and diagnostics really is a leg of the stool, right? So you have people, you have process, and you have technology, and you really cannot exist without those three things working in tandem. So FDD is that technology that helps you innovate and automate, but without the people and the process, it makes it very difficult to scale and to truly automate it out. So having a good process, having good people, those will make your FDD program successful. Okay, so we're going to talk about the highest impact issues. Again, I'm showing you a Clockworks Analytics interface because that's what I have access to, but most fault detection and diagnostic programs will have some form of prioritization tool that will tell you what your problems are on your campus. It'll look slightly different, maybe the priorities are slightly different, but most of them will have a prioritization and a cost assigned to it and a problem statement. So in this case, we're going to come in, we're going to look at our diagnostics across this particular campus. We see that the top 5-6 issues are related to the air handler, and we have one related to the heating system. We are looking at energy, comfort, maintenance scores, and the energy cost associated with the problem. So when we're looking here, we come in the morning, we decide what we want to work on. It's right there, this $93 per day waste of this air handler. So we're saying yesterday, we threw away $93 on this campus. Let's go take care of that problem. So let's take a closer look. So we click into this one. This is going to give us your diagnostics report. It's going to give you that problem statement that we talked about and those possible causes. It's going to give you when the issue occurred, and it's going to bring those performance trends to you. As an energy engineer who used to do lots of consulting, this performance trends thing was really game changing for me, because it's that problem where you'd go to a spot, you'd see the issue, you'd go to look at it, there's no trends set up for it, or maybe the trends are at odd states. You have to know which points to pull them into Excel, massage that data. It's just cumbersome, takes a lot of time. this brings it to you, right? It already says, these are the issues that you need, these are the points you need to look at over the last day to see this issue occurring. Okay, and then we're going to review the problems for possible causes. So we're gonna look at the first one. So the primary problem is that we're wasting energy, right? We have simultaneous heating and cooling. That's our highest priority. We wasted $93. It tells you how it got there. And then it tells you the symptoms of that simultaneous heating and cooling. So we've got another problem that's happening on this same air handler and supplier temperature that's lower than set point. Okay, that seems like it could right? And then it also gives you the root cause, right? So all in one piece, it says for this air handler, you have simultaneous heating and cooling, you have a supplier temperature that's lower than set point, and you have cooling occurring when the cooling valve is closed. My hunch is those three things are related, and the root cause is that cooling valve, right? So let's dig in a little bit deeper. Let's investigate. So we're looking to see, when did this issue start? So we see in our diagnostics report that it started at 8 o'clock in the morning yesterday. So we know, we have the history of where it was. And then we're looking to see how severe is this issue truly. And I look at the first graph that shows up that shows me all of my supplier temperatures. And I'm seeing that my supplier temperature is 5 degrees below set point. If I were a technician, I had a campus I was taking care of, and I went in the morning and I looked at my BAS, like I always do, to see if there's anything that sticks out before I go and take care of my work for the day. I don't think I would prioritize the 5 degrees below set point. It's probably not impacting the occupants. They are probably reheating to overcome it, but not a lot. And I've got, you know, a toilet leaking across campus or whatever it may be. So I would maybe stop by there before lunch, or maybe on my way home if I had time, but it wouldn't be something I would prioritize. But I look further and I see that when I look at my preheating coil and my cooling coil, I see something strange. So I see that my discharge air temp set point is 55 degrees and my cooling coil is closed. So this little dash line here shows me my valve position. So I should not have any chilled water going through that cooling coil. I should not see any temperature difference across that coil, yet I see a 50 to 60 degree temperature drop. That would send off some alarm bells to me that there's something wrong. Most likely it's the chilled water coil, but if I really want to know the severity of it, I'm going to look at what my heating coil is doing too. And I see that my preheating coil, which also controls to my discharge air temp, I have good programmers on my campus. They know what they're doing. They would never let a heating coil and a cooling coil operate at the same time. So clearly my control system is being tricked, because it looks at this cooling coil and sees that it's closed and says, I'm 5 degrees below set point. I'm going to open up my heating coil and I'm going to go for it. So I'm 100% open in my heating coil, and I still cannot overcome this leaky chilled water coil. It's leaking so badly. I still cannot get to set point. So if we were to leave this going, that thing would just chase it all day long trying to get to the set point. So now I know that energy impact is very high. And I looked at my air handler for any other kind of faults that are coming through. Ventilation is fine. My fan performance is fine. This is just the coil. And so I know my root cause. I need to repair that cooling coil. So I create a work order and I say, go fix that coil. I know exactly what it is. And either I can go perform that work, or, you know, I'm busy today. I can send it to Jack and he can go do it. And he knows exactly what he needs when he goes out there. He has the right tools. He knows it's the valve, and he goes and fixes it. That's a much shorter timeline than going to troubleshoot, checking all of your systems, looking to see if it's the valve, going back to the shop, getting the parts you need, maybe getting to it in 2 days because you have 7 other things that come up at the same time. You're going, and when you go, you're ready to repair it. Now, I will address this too. So this idea that you're creating a work order, there are lots of different ways that you can do this. The fault detection diagnostics program will usually have something embedded within their program to track that issues are being resolved or handled, but not always. So that's an important thing when you're talking to a provider and you're talking about workflow and how you're actually going to use this on your campus. It's very important that you make sure that they're working with your existing processes and procedures and helping it become part of your workflow, just regular part of your day. as much as possible, right? So you're not doing a lot of writing things down on pieces of paper. We need to be moving into things being tracked in a database, resolutions tracked, and issues closed. So whatever type of interface they have, whether it interfaces with your work order management system or not, whether it's an embedded module, those are all things that you can talk through within your organization of what you think is needed, but then also what your providers can actually do. But the most important thing is that you can see that the repair fixed the problem. So you go the next day, you open it up, your diagnostic, and you see that the repair was completed at 2 o'clock that day. And you see that you no longer have that temperature difference across your coil. I think I have a question here. Oh, I don't. Okay. Great. Yes, feel free to ask questions as you have them. Okay. So the next thing, I want to take a pause from showing the examples. I'm not going to spend a lot of time on this slide because it is a little complicated, but it's sort of a good point to talk about, is when we're talking about quantifying savings, energy savings specifically, a lot of institutions look at fault detection and diagnostics as purely an energy savings tool. And it can give you great gains in energy savings and optimization, but there is so much more that it can do that we will talk about in a bit. But I want to pause and talk about this energy savings because there's really two ways to capture it. One is to look at your bill and look at your baseline energy consumption to your new energy consumption and call that savings and say, there you go, I saved you $10,000. But in this particular instance, the issue was fixed within a day. So you will not see that huge energy savings on your bill. And you never want to incentivize your institution to let things sit so that you can show that you achieved savings. So this is where we get into talking about that avoidable cost or the cost calculations. And as an institution, you need to have that conversation around how comfortable you are around the idea of avoidable cost. And is this something that you are going to use to prove out that the tool is truly saving you energy? And if so, asking how that avoidable cost is calculated is very, very, very important, because not every FDD solution does it the same. Lots of different good methods, but you just want to make sure that the method that they use is transparent and that you can see how that number was achieved, and that you believe that the numbers are accurate. So some of the models will do what we call rule of thumb costing, which is taking, I know some information, I don't know everything, some of it's real time, some of it's not, I think we're about here, which is great if what you're looking for is just prioritization. I just want to know, is this a big problem or a little problem? That's probably fine, hard to maintain, not very accurate, but it'll get you in the right, probably ballpark. The other option is to do more of like a regression analysis automated modeling, where you have a true baseline energy consumption if everything is operating as it should versus actual. So actually taking regression analysis, looking at during this time when this problem would happen, looking at your TMY2 weather data information and coming up with an actual minus an ideal cost and sharing how that information is acquired. So that's very important to ask those questions if it's important to your campus. So in this particular example, the rule of thumb costing was actually over two times the actual savings. So if you were using this to prove out that it truly is saving you energy on your campus, you would be doubling the truth. So just something to talk about. So in this case, we were able to capture $11,000 in annual avoidable cost. If you looked at the bill for this instance, it's a blip. You don't even see it. So it is really important that if energy savings is important to you, that you believe in the energy calculations that are coming out of your tool, and that it's something you can stand behind.
Katie, we have a question. Scott is asking, so is the assumption calculation built based upon problem that would not have been repaired?
Yes, so this is a really great question. I'm glad you asked it, and I was prepared for it because I would ask the same one. So a lot of the things that I think this is another reason why it's important to be transparent what assumptions are being made when the calculation is provided. Because in reality, would this campus have allowed this leak by to happen for us for an entire year? Probably not, right? And actually, this calculation doesn't look at the full year. It's assuming that it's only during the outdoor air conditions where this problem would happen. And then it also says we think it probably would only happen for half the year, 55% of the time or something. So, but if you still thought that's a bit much, I think we'd find it in a month. You have enough information at your fingertips to say, okay, instead of multiplying it by 5 months, I'm going to multiply it by 3 or whatever the number is, and you can knock that number down when you're reporting. And that's why I think it's important. It's a colleague, right? So you have people on your campus that are very smart. Most likely you have somebody who works in energy management that will question these results and be able to make some smart decisions on truly what you should be reporting, especially if you're talking about annual avoidable costs. There are some things that truly, I believe, would have happened forever. But this one in particular, I think, you would have found a valve that was stuck closed when you changed seasons. So I'm glad you asked that question. Thank you. Okay, we're going to run through another one. It's a similar problem, but there's a little nuance that I want to make sure that we point out here. So in this case, we've already done our campus-wide look, and we've already decided that we have a problem at the biology building or at a building. And so, sorry, I'm not supposed to give specifics. Okay, so we go here and we look at this specific building. We know this air handler has an issue, and we're looking back at daily issues that have happened over the past 6 days. And so when we first are looking at this, it's a $3 per day cost, which is not nothing, but also probably not our highest priority across campus. But then it starts to waste $1,700 a day, which it's time to prioritize when you see that. So again, you have your diagnostics report, you have a problem statement, your issue occurrence, your performance trends. And we're looking at this issue of simultaneous heating and cooling has popped up again. So we see here that we're wasting on this particular day that we dove in $1,500 a day. The symptom, again, our supplier temperature, except this time it's higher than set point. So it's a little bit different. You can't compensate for it with reheat. So you might have some occupants that are impacted. And then heating is occurring while the preheating valve is closed. So again, we've got another valve that's being finicky. So we investigated a little bit more. We looked to see when the issue started. In this instance, the issue has been ongoing. It's happened for a couple weeks before anything was responded to. And so we look at that first one that shows our supplier temperature, and we're 15 degrees above set point. So if I was a technician looking at my BMS in the morning, maybe I would see that as a problem, but just depends on what I had going on that day. But I'm going to look and see how much of an impact this has on the zones that I am providing so much warm air. And because we have a platform that's built to pull in data and create relationships between different pieces of equipment. So you could look at things systematically. We understand that this air handler serves 30 zones. We know what those zones are. We have all the data on those zones in one graph. So we can look at this and say, okay, I know in this building, they have these things, these sliders, these thermostat sliders on the walls. I don't know how many of you have those on your campus, but where you can adjust your set point plus or minus 3 degrees from that base set point. So if people were hot, I would anticipate they would take that slider and they'd push it down. They'd say, I'm too hot, I need cooling. So you'd expect these 3 points are showing you the minimum set point that somebody has in there of those 30 zones, the maximum set point someone has, and the mean. So I would expect this mean to be low if there were a lot of people on the campus demanding cooling, and it's at 75. So I don't think very many occupants are sitting in their offices too hot, assuming they know how to use the slider. But let's go to another picture just to verify that. So this one actually shows you the distribution of your VAV box dampers. So your air handler serves air to each of these zones, and this damper will modulate to bring in more or less air depending on whether you're in heating or cooling or what the demands of that space are. If you're in cooling, you would expect those dampers to be open because you want as much cold air as you can into that space. So I would expect to see lots of dampers wide open. If I thought that there were lots of zones that were demanding colder temperatures. So I see here this little green sliver. That is the percentage of dampers that are open at 90% or above, so that are calling for cooling. And I don't see a huge distribution there. So my conclusion to make here is that I'm not really impacting my occupants very much. I don't think I need to call, the building coordinator and say, hey, we're on it. We know it's coming. I don't think the occupants quite know this is a problem yet. So let's look at how severe the issue is. So again, we look at those pesky coils and those pesky valves, and we see that our preheating coil valve is 100% closed. It's not open at all. And we're seeing a 60-degree rise across the coil. We would not expect that to happen. But on top of that, when we're looking at severity and how much of an impact this has on energy consumption, we see that the coil that comes after it is then saying, wow, I have 140-degree air up coming at me, and I need it to be 55, and I am open 100%, and I still can't get there. So that's why you're above set point, is that your coil, your cooling coil, is trying to overcompensate for that, and it can't get there because your heating coil is just going nuts wide open. So I know I really need to repair that steam valve. So again, I create a work order, I have all the right pieces and parts, and I go out there and I fix the problem. So that in this particular issue, the pneumatic lines were blown off of the C2P valve. So actually new high temperature pneumatic lines were put in its place to hopefully prevent this from being a recurring problem. So the pneumatic lines are sort of melting off of the valve. So you can see again, the repair is complete. And in this case, because the problem was ongoing and did happen for a long time, you can see it in the meter. So this is what I really wanted to talk about when we talk about energy savings and how to quantify it, is in this particular case, when you look at the steam meter, this is interval data for your steam consumption for an entire year. You see when the problem started to happen, and you see when it was repaired. So this annual avoidable cost is a really big number. It's $118,000. If I was an energy manager, I would look at that and I'd be like, ooh, that doesn't seem right. I want to know how they got that number. So I can see the methodology that's used. I can validate it with bill data. In this particular case, I can say, it only was a problem for half of the month of June. I wasted $10,000. But I can also say I would probably know that this is a problem when I get into a different season. So maybe I'm not going to take that full $118,000, or maybe I will. You could make that sort of educated decision and validate that calculated cost. Any questions on that one? Okay. So that's when we get into reporting our impacts. So this one I want to show as the most important reason why you need to track what you're doing, closing out issues, capturing that avoidable cost or that energy savings, whatever methodology you're using, is so that you can tell your story. So you can say, this is, I pulled up a campus client that we had, that you can say that they have completed 264 tasks within the last 12 months, work orders for lack of a better word, and they have accumulated $300,000 in avoided cost. So you also know that there's 47 tasks that are open, you're still working on it, you're still chiseling away, and that has $50,000 in avoided cost. So what that tells me is we've done the big stuff, and we still have issues laying out there that we need to close out, but it's not $300,000 worth of avoidable cost anymore. We're taking care of a lot of that. We've got $50,000 left. Let's go get it. But then it also kind of shows you the rolling cumulative total you can get if you leave it, right? So just being able to do that reporting, quantify what's being done, quantify what's still out there. It's just one more way to prioritize and look at your information. Okay, so let's talk about how FDD can really transform how you do maintenance on your campus, or at least can be a help. Don't laugh at this slide. It's supposed to make you laugh. So I pulled up what it takes to maintain a typical building. This is recommendations by an ASHRAE standard for what PMs to perform and how frequently. if we were in person, I would make you raise your hands of how many of you truly do all of these PMs at this frequency on your campus. But I can say from my experience, talking to people, it's not many. So the gold standard of, doing a VAV box PM quarterly, I don't know that happens very often. But this number is, you'd be doing PMs, 955 PM checklists per year for just this one building that is pretty small compared to a lot of campus buildings. So the foundation here is that with FDD, you can supplement some of those PMs that maybe you're not getting done, or you can make decisions about how much of your PM to perform and when to perform them. Because, if your FDD system can perform checks on each of these pieces of equipment that sometimes would supplement some of those checklist items on your PM, it would potentially take the place of that. On top of that, by running FDD against systems, you may not need to PM certain pieces of equipment. You might be able to just let FDD tell you when they're close to needing repair. So again, this example is with Clockworks analytics. It's going to be different for any FDD provider that you have, the number of those analytics and what they're able to do. So again, important questions to ask when you're talking to your providers, when you're interviewing them. So we're going to look at this in kind of a calendar view. I thought this is so impactful. So here's a week for a technician doing PMs in a dream scenario. They show up, they do that chiller PM on Monday, they get the AHU in the morning on Tuesday, they do some semi-annuals on their VAV boxes, they got the boiler or cooling tower, no problems. No one calls them, nothing's broken. They just go about their day, they get that PM done, they check those boxes, they say, Ashray, I'm doing exactly what you want, but this is reality. I think the studies are showing that greater than 55% of work orders in buildings are reactive maintenance. I think in facilities on campuses, it's probably higher in a lot of places. But things get upended. That quarterly chiller PM that you wanted to do got upended by this BS alarm with your air handler. You don't get any of your VAV boxes done on Tuesday because you're getting comfort calls. Everything gets pushed. And then you go back and you look at the end of your week and you've done, 55% of your PM that you were supposed to initially do, and then you're always working from behind. So let's look at one example where you might be able to use FDD to supplement some of your PM work and to help you get your feet under you with maintaining your facilities. Let's just do highest impact work. So these blue squares would be where you'd be doing something that's FDD related. So maybe on Monday morning, you come in and you look at your FDD software and you assign some work orders. So you're planning your FDD response work. You're not stopping what you're doing and going and responding to a fault. You're planning it and you're scheduling it. You're saying Tuesday and Wednesday, I'm going to hit these 2 items and I'm going to get those done this week. And by doing that, when you hit that AHU that had a high kW per CFM that was maybe telling you your alarm, your fan was probably not operating optimally, you upended that BAS alarm for your fan failure. And maybe by hitting that fault that came through to recharge your chiller one refrigerant, you're getting ahead of that alarm that's coming out saying you have a high discharge air temp on your chiller. So it's using that highest impact work to prevent those alarms from happening. You're planning out the work, you know what you need, you have the equipment you have, everybody's ready. It's a much less expensive way to do work. And then the second level, once you kind of get your feet under you, you understand how you're using FDD, you understand the tool. Now we can do what we call enhanced preventive maintenance. That's where anything that's a blue box is as a result of FDD. So that's where you can say, maybe I don't need to do any PMs on my VAVs. I'm strictly going to respond to high impact faults, and I'm going to prevent those PM tasks or maybe make them very small. Maybe I can cut some of my chiller PMs in half because I can do a lot of it looking at analytics, say with your air handlers. So once you understand how your FDD program can supplement your preventive maintenance program, you are in the sweet spot of quarterbacking rather than firefighting. So instead of dropping everything, not getting anything done, you are in a more planned, routine, proactive, preventive mode where, yeah, I know I'm not going to PM all my VAV boxes quarterly, but instead I'm going to choose to do FDD on those VAV boxes. I'm not going to do my air handlers quarterly. I'm going to have FDD running on those air handlers, and then I'm going to do them semi-annually when I do a season change. And maybe I only do half my PM tasks because I know that FDD is running and I can trust that what they're giving me is going to find any of these other issues. So it's really being smart about how to supplement your maintenance program to get in a position where you're not constantly firefighting and reacting. You're being proactive and preventive. And by having that last D, that diagnostic, that information that's coming to you, the timeline to troubleshoot problems and make corrections is much shorter. So you're also saving a lot of that desk time. So once you're into quarterbacking, you can do some of these other things that are also insightful from an FDD program. There's lots of them. I'm going to give you 2 or 3 examples. This one is really at the front of our minds because of COVID, where ventilation quality is becoming very, very important to our occupants on campus. And by having a system that pulls in all of this data, knows what type of systems you have, knows where your dampers are supposed to be or not supposed to be, you're able to get these kind of insights where we know I have 400 air handlers that I'm looking at every day. It's impossible to check the outside air dampers on all of them by sight. This will tell me that over the last 7 days, I had 450 instances where my fresh air dampers were below minimum. I had 100 air handlers with IAQ issues out of 400. And so it really allows you to kind of tell the story of here's where we stand from a ventilation standpoint with our air handlers. But another really big one is our zones. So if you have an air handler that's providing the correct amount of fresh air, but half of your zone dampers aren't working, it doesn't matter. You're not getting that air change rate. And that's an even harder one to keep an eye on. I mean, we're talking about 10,000 zones across this campus. So to be able to say, hey, look, these are all the ones where my supplier flow is lower than my set point, I should probably go take a look at those. And maybe I'll only look at the ones that are 50% off of set point or higher. And I'm going to prioritize and look at those. So it really allows you to take that information and make it actionable. And here's some real world examples of when a campus was preparing for the fall, some of the things that they found using FDD that were related to IAQ at the zone level. And none of these findings, I don't think they will be surprising to you. Stuck fire dampers, loose set screws, calibration problems, programming overrides. These are all things we see every day when we're going to respond to hot or cold calls. And also things that if the paradigm hadn't shifted with COVID, we probably would never look for unless a comfort call came in. So stuck fire dampers happen all the time. We don't have a lot of visibility into them. You know, they oftentimes will just close on a blue and they're hard to find. And so these are all very important things to take a look at. So these are just, you know, a handful of examples of things that were found. The other thing is, yes, we talk about energy savings. We find things that are broken, like our economizer is not operating when it should be. That's a problem. But there's also opportunities that can be highlighted with FDD because they know what your systems are, they know how they operate, they know how they're supposed to operate, and they can quantify the cost. They can say things like your air handler doesn't have a reset, and if it did, you'd save $10,000 a week or a month or whatever that number is. Your heating system, you know, your return temp is low and your hot water temp loop differential. You have a low hot water temp differential. So you're not getting great efficiency off of your boiler. Same with your cooling system and your zones. Maybe your zones are operating when your building is unoccupied and they're frequently coming on and pulling your air handler on at night. These are all things that when I was a consultant in energy management, I would go and create this list of ECMs and charge my client, you know, you need to do these things. I see that you're running when you're unoccupied, but in this, it's real time, it's available to you at your fingertips, and it's smart. It can give that cost savings real time to you for how much you wasted the prior week, the prior day, the prior month. The other thing that it can really do is help you to improve your standards, right? So if you notice that you're getting a lot of faults for different things that are not operating per, new design, you can start to make those changes and then make it part of your standard operating procedure for your sequence of operations. And the last one I want to show you that is also very impactful is this improved construction handoff. So even the best campuses that have great turnover for new construction will still run into issues with things that either, we weren't aware of on the maintenance side that the construction made changes to, or, it's a large beast to swallow. But this is an example of a building within the first year, it was fully commissioned, issues that were found. Again, I don't think any of these will be surprising to you. Coils that were valved off, actuators that were not installed properly, sensors that were out of range. These were all things that could be handled by warranty. So not on our dime, on the contractor's dime, all within warranty, and you find them fast, which is why that's so important, because if you let this drag on until 2 or 3 years later, when you start to get familiar with the building and how it's supposed to operate, and you get that institutional knowledge, it's too late. And then you're fixing all of this stuff on your dime. But another really important thing here is this example. I mean, first of all, lots of issues, but the bracket was already bent. And it actually led to a design standard change to not allow this type of device to be used in new construction projects, because it was something that, within the first year had already worn out. I think I have a question. Yes.
Yes. Do you see Scott's question or statement? Would it be great to demonstrate? It would be great to demonstrate warranty issues as well after opening new project.
Yes. So that's exactly what these are, Scott. So these are warranty items that were identified after construction had started. It's just a sampling of them. I just grabbed it out of the tool. So yes, exactly. Great for that, but I think also great for bridging that institutional knowledge gap. So I know in my experience in higher education, when a new building comes online, especially recently, the sequences, the equipment, it's all really high tech. The sequences can be very, very complicated, multiple pages on how to make a zone comfortable. And so this does sort of help, like little training wheels to get up to speed on how everything is supposed to be operating by bringing you kind of, here's the expected mode we would see, and here's what we actually see. It helps you get more familiar with that building quicker. So those are just some examples of, when you start to use the tool, build it as part of your operating procedure, get it as part of how you do work day to day, it leads to investing in your infrastructure rather than spending to fix it. And making sure that we are truly keeping things running and humming, and then you're starting to get all that cream off the top, right? You're looking at optimization, you're looking at ways to improve our design standards, you're looking at ways to really, get even more out of the tool than just strictly finding things that are broken, right? Okay, so this is the last little part. Oh, I'm right on time, I think here. We'll have time for questions at the end. So I'm calling this evaluation criteria, but I really think it's important to, these are really just things I want you to take back. If you're thinking about doing FDD on your campus, things to take back and talk to your teams about what's important to you. So I can tell you what I think it is, but I think until you know where are your strengths, what are things that your organization does very well, and what are things that you don't. And then trying to find an FDD provider that can really partner with you to make sure that it fills those gaps, so the things that you're not great at, and capitalizes on the things that you do very well. And so these are more just kind of ticklers of things to think about when you're looking at implementation. Here, I'm going to see what question is first. Oh, it's just the evaluation. Okay, great. Okay, so I'm going to start with the business case. Everyone always asks this. I can't tell you a firm number that's the same for everyone, right? But I can give you sort of some studies that I think are sound and good and based on solid data, and also don't have private business interests, right? So on the energy saving side, the Berkeley lab did a really wonderful study. It was a 5-year study called the Smart Energy Analytics Campaign. It's very well documented. There's a great report on it where they tracked real life users of both energy information systems, so sort of energy metering comparison, and fault detection and diagnostic systems. And they submitted their true, I participated in it when I was on the higher ed side, so I know what they asked for. They submitted true bill data that was compared year over year, and they quantified the energy savings and then just sort of averaged it out. At the beginning, they did not have a lot of participants, but towards the end, they had a pretty good crop of people that were using fault detection and diagnostics. I'm not sure that if I were in facilities trying to sell this to my AVP, that I would tell them they're going to get 27% energy savings, right? You might get 40, right? But I think, just be really cautious about what you're talking about when you talk about savings. Is it true bill savings? Because you never want to get in a situation where you're incentivizing your operations group to sit on problems so that they can prove out the savings. So just make sure you have that conversation as an organization on your feelings on avoidable cost and energy savings. I think the more interesting thing is the operational savings, to be really honest with you, even though I have an energy background. And that is because of really trying to do work better, doing less reactive work, more proactive work, more predictive work, avoiding those alarms, avoiding the on-call calls, really trying to get to where your feet are under you and you're getting the cream off the top, right? And so this is a Pacific Northwest National Laboratory, which I think is a very reputable organization, did a study for O&M best practices. And these are some of the numbers that they have gathered on elimination of breakdowns, downtime, reduction in maintenance dollars, and increase in production. So I would encourage you to reach out to those resources when you're looking at how to make the business case. See, I have a question here, I think. Oh, just remember to complete your evaluation when this is over. All right. So these technology checklists. Again, these are just ticklers I want to put in your brain as a takeaway for what to think about when you are looking at putting fault detection and diagnostics on your campus. And the first main one is analysis accuracy. So it's very important that you have a provider or a software that can demonstrate the ability to suppress false positives. So you don't want to get in a situation where you have alarm fatigue, right? We don't want to recreate that problem. We want, if it gets identified, it's an issue as much as possible, right? Where you avoid those false positives. And if you get a false positive, it's easy to correct. It doesn't take, 10 hours of desk time and reprogramming. That your rules are aware of each other. So that was some of the great examples that we showed in the use cases. So when you saw that your discharge air temp was above set point, did you also know that your valve was stuck? Did you also know you were doing simultaneous heating and cooling? But then also that you're aware of a hierarchy. So yes, I am providing warm air to spaces, but are the impacted VAV boxes, do they care? Do the occupants feel that? And understanding those nuances, I think, is very important. So make sure that your FDD software that you're looking at can do those things. Automated root cause analysis. This is that final D. So it's getting to the finish line of here's what the problem is with root cause explanations. And then also it's looking at kind of based on these 3 things that I'm seeing, I think these are your root causes, instead of kind of giving you a list of 12 things to check. The automated quantification of impact. This is that cost, energy, and maintenance, IEQ. These are all things that if they're important to your organization, you want to make sure that it's as automated as possible. We're not trying to create more work. We're trying to create less. So as much of this information to you that can be automated, the better. So if energy cost is very important to you, try to make it as accurate as possible. Make sure that it really is using real-time information. If IEQ is important to you, make sure that there's some scoring or some prioritization associated with that, or some way to look at areas that are impacted by IEQ, indoor air quality. And then M&V. So that if they are doing energy savings calculations, that they are transparent and that they're using good practice.